So welcome back to my YouTube channel. There's going to be situations later in your math career where you're going to be given this expression, where it's going to be a square root expression. It might involve a limit, or it might involve what's called a derivative or even a slope. And you're going to get told you're going to have to evaluate h at 0, either h equaling 0 or h approaching 0. So as it stands right now, you can't evaluate this at 0. However, if you turn this expression into an equivalent using rationalize the numerator, you would be able to actually come up with a value. Or at least, if anything, come up with a value which leads to what they call a limit. But main thing you need to worry about right now, let's focus on let's focus on the technique. Now, when you follow the technique, there is a conjugate of the numerator that you have to use to work this. That's the conjugate of the numerator. Now, the reason why we do conjugates, you're going to go ahead and multiply the two numerators, and actually, it doesn't publicize it very well, but it is in the form a minus ba plus b, which leads to squared expressions. Right? Yeah, it leads to a difference of squares. That was a waste of 2 seconds, wasn't it? Let's go ahead, and if you square the square root of 16 plus h, that's just going to be 16 plus h. If you square the 4, that's going to be negative 16. The bottom is going to be h times the conjugate expression, for lack of a better term. Now, if you notice on the right, the 16s add up to 0. Now I'm going to go ahead and I'm going to take this to another screen. Remember, you can always pause, you can always play it slower, you can always look back and re-explain, but this is what I have now. I'm going to change. Oh, can I actually do it? Hang on a minute. So now I have h over h times . Yeah, that's what it was, right? So what you also have to realize is that the top, it doesn't like to say what it really is, but it's really h times 1. Now, because of the fact that you have h times 1 on the top and you have h times the conjugate expression on the bottom, you can cancel out the h's. Now, if you have to plug 0 into this expression, you will actually get a legitimate value. You just can't plug it into the original. So like I said, very useful in the study of limits later on in your career, or derivatives. So this is your final result. Thank you, and tune into plenty of other videos.